Hi, Gabrielle. It is Thursday, October 15th. We are going over homework from 3.2. All right, let me get this off here. Okay, so I heard Alfredo ask about problem 20, but I helped Gabby on 20 and Sylvia, some other people in tutoring yesterday, so I'm going to let those people talk to you in class. All right? But is there another problem? Yes?
47B.
Okay, 47B. All right. So here's 47. Zoom in on this a little bit. But not that much. Okay. So here's 47. And yesterday we did a problem where they gave us a table, correct? That had the outputs and then it had the derivative. And again, the derivative means the rate of change, right, at that moment on your graph, or the slope of the tangent line. That's what that derivative means. So now we have a problem that's not a table, it's an actual graph. Okay, so you want to be familiar with being able to find problems, given a table or given a graph, or maybe given algebraic equations. So we need to find, so someone said b, correct? We want to find the derivative of v at the value 5. So let's first look at what v is and how it's defined. Okay, so here's v, and it looks like it's f of x divided by g of x, correct? Okay, let's take the derivative of that. Which should actually be pretty simple if we know the quotient rule, because we don't actually have to know what g of x is or f of x is. So who could tell us quotient rule? Who can apply it? Elizabeth.
G of x times f prime of x minus f of x times g prime.
Okay, so I always like to, I know she's just kind of saying it off, but to help me memorize it, right, I always say I'm starting low. So good, I'd have g of x squared, right? And then we'd have g of x, as she said, times f prime of x minus f of x, and I know I'm kind of going into writing this problem, times g prime of x. Okay, so that is our quotient rule. I'm going to continue that over. All right. So we now need to go back and put in, 5, correct? All right, so I'm going to go to a different paper for a second and do that. So I'm going to go back and put in, so v prime at 5 is going to be then g at 5 times f prime at 5 minus f at 5 times g prime at 5 all over g at 5 squared. Oh, you can't even see that. Hold on. Okay. And let me make this not so big. All right. So here's where it's really important to understand the function notation. So when we say g at 5, this is referring to what is the output on our graph at 5 for the function g, correct? All right? But when I say g prime at 5, this refers to what is the slope of the tangent line, right, at 5 for the function g. So those have two different meanings, okay? So it's really important to understand the difference there. So let's go back and find g at 5. So I'm going to go back to the graph, and I'm going to highlight g. Highlighters are always nice, I think. Okay. So where is 5? It looks like, here's 1. So 1, 2, 3, 4, 5. Looks like G is 2. Okay, so G is 2. g at 5 is 2. All right, so I'm going to go back. So that means I'm going to have a 2 here. It's going to be squared. So 4, and I'm also going to have a 2 right here. All right. Now let me go and find the derivative of f at 5. And I think while I'm at it, to save time, I'm also going to look at what is its output, because I'm going to need that too. All right, so let's go back. So at 5, my f is this function. And it looks like right here, it looks like its output at 5 is what? 3, okay? So f of 5 is 3. But what is the derivative at that point? What is it? Say it a little bit louder. Negative 1/3. How did you get that, Sylvia? Sine graph. How did you get the derivative? Okay, that's right, because this is a line right here. It's linear, which means it has a constant rate of change. So, in fact, we know, right, if it's linear, the derivative is just going to be the slope of that line, which in this case it's what she said, negative 1/3, okay? So I'm going to go back. While I'm at it, just to save time, we do need to still find g prime at 5. So right here, it looks like this is a positive slope. It's also linear. Looks like if I go from here to here, I'm going up 2/3. So yes, it is 2/3. All right. So I need to go back and plug those in. So let's go back. So this was negative 1/3. This was 3. And this was 2/3. Okay, so let's carefully, do the multiplying here. All right, so Cameron, 2 times negative 1/3. Good, I got negative 2/3 minus, okay, 3 times 2/3, Alfredo. So good, we got a minus 2, and that's all being divided by 4, okay? So I have a choice here now how to simplify this. I'm dividing by one term, so could I actually just divide these both by a 4? Okay, that's one option, okay? The other option is I could actually subtract these and then divide that by 4, okay? So we have a lot of options. I'm just going to divide each of these by 4, and dividing by 4 is the same as multiplying by 1/4. So if I multiply this by 1/4, I'm going to have negative 2/12. And yes, I could simplify that, okay, but I didn't yet. And if I do 2 times 1/4, I'm going to have 2/4. Okay, and I'm going to leave that for you guys to finish, because you should be able to combine those two fractions, right? Okay, so if you have other questions on this homework, you can talk to me in class, all right? But I would like people to take out their notes.